Hello, thank you for tuning in to another basics video. In this one I'm going to be sharing with you the problems I had with my MaxFind dual motor drive kit. Let's get into it. I'll start playing this footage. Right away the first problem I had was that the fitting instructions they include, they actually printed too small, and it's a sticker, you stick it on your board and you use it as a guide to drill holes into your deck, and it was wrong. Look, it's the wrong size, it's too small. I wonder how many people destroyed their decks using that. Like, that's ridiculous. No one even checked it, so I ripped it up, threw it away. Go watch my video if you want to see how to install that correctly. Here I am riding the board for the very first time. Listen carefully. I'm on a very smooth surface. The motor's buzzing. It's buzzing, like from the very first ride out of the box. And then look, this is after maybe 3 or 4 rides. Look how much the wheel has stretched out. And I can very easily move and stretch it with my hands. It's garbage. You can't ride on that. And to my surprise, one of the tabs on the battery cover door broke off. I couldn't believe that. How's that happen? Shitty design. Also, one of these broke. There's 4 plastic mounting posts that you screw into. I'll say that one got damaged by me trying to put the thing together like it was a Formula 1 race car. But I had another one break later, and I had to melt it back together. So I contacted the manufacturer because I wanted to get replacement tires. I actually wanted to maybe even buy them. I didn't care. I would have bought them if it was proper. Like, maybe it was just a bad batch. Yeah, they should have done a solid and sent them to me, but instead they sent me this video. Rides the board, it makes kind of a similar noise, so they basically acknowledged that it has a problem. But if you look, those motors are different than mine, and they didn't actually really show how I'm supposed to do it. And even if they did show how to do it, again, it's a different motor, and he rides here and it's quiet. Basically shimmed up the tire so it has a better interference fit. But if you look, you can see where the tire is wearing. So I've already put some grip tape on this one and just started recording, and I'm fitting the polyurethane tire back onto the motor. Took a moment for me to stretch it over the grip tape and get it back on, but that's good. You don't want it to be loose. It's not supposed to be loose. It shouldn't be loose after your first ride, and it's crazy. Once it's back on, look how much of the wheel has actually worn away. And I would say that's from less than 50 miles for sure. Way less, probably like 20 miles. So here I am doing the other side. You gotta clean it up first because you're riding it on road. It gets all kinds of crap in there. There's oil, tar, dirt, sand, grit, all on the road. Take your grip tape, cut it to the right length and width, press it down very firm, use a tool to get it into all the cracks, crevices of the keying on the motor, and then stretch your wheel back over. Here's another closer look at the polyurethane tire. You look at all the little artifacting where the tire is wearing, and this is from the wheel driving forward. You see from braking it still has a very clean line, but where it drives forward it's just wearing. The wheel is so loose it stretches and skips, and you get this really hard to describe. You basically get 4 bumps every rotation. 83 millimeter wheel, so you do the math how many vibrations that is per kilometer. That's crazy. So again, the same thing, just take time stretching it over because you don't want to push the grip tape off. And you see up close it shims up the space pretty good, but there's a huge hole in the wheel just from where it wore out. It's so soft. It's crazy. Why didn't they glue it on? It's like they meant for it to be a replaceable wheel, but when I reach out to them to buy the wheel, there is no part. And you know what it is, I think? Because I was looking at photos of a lot of their products. They've had many iterations of their motors, and if you have a good motor, you don't keep revising it and updating it. And I think their current kit and boards, like even in the video they sent me, you see the wheel, the motor was different, right? It was a newer version than this one. They mailed me some old garbage. They sold me some old garbage. It didn't work, and when I reached out to them, there was absolutely no support. So here I am reassembling it for, I think it's 3 millimeter, what do you call those, hex nuts? Get those on there good and tight. And then this was after 1 ride. This is what happened. Because the polyurethane is so soft, it stretches out, and it's not even summer here. I'm riding in spring, so the roads aren't even hot, and I'm light. I'm 160 wet carrying all my gear. Terrible. You can see that, right? So it went from bad to worse. This was the manufacturer's recommended solution. I mean, she might like it. Sure does shake the shit up. Look at that. If you look on the inside, you can see the motor's not vibrating, but it's just the tire. The tire's going, the polyurethane wheel is going crazy. There's all the glue from the grip tape stuck on the motor now, and for whatever reason it's not spinning and it's knocking. It's crazy. So basically, what the manufacturer told me to do to fix it made it worse. Significantly worse. So after offering me absolutely no support, their recommendation, if you want to call it support, I don't call it support, actually destroyed the motor. So here I am tearing in even deeper into the motor than I ever thought or I would or wanted to. I had absolutely no reason to tear into the thing like this. And those little transistor looking things are Hall sensors. They sense the magnetic field of the wheel because it's got a rotating magnetic field. It knows what polarity the magnetic field is, so it knows what polarity or phase to send into the windings of the motor. Basically, it helps it to sense the speed, the electrical RPM of the motor. And then this really shocked me when I looked inside and I saw all these blobs of solder, cold blobs of solder that clearly fell while the wheel was spinning because you can see they are elongated. It's crazy. And it's not even a small amount of solder. Of course, my genius mind tried to use a screwdriver, forgetting that those are magnets. But yeah, look, it's all loose. They claim it's a 500 watt motor and you just got all that floating around in there. Super safe. I wasn't even expecting to see that. That's not the failure or fail mode that I was investigating. If you pay attention to the orientation here, we're looking at it from the tail. So the bottom of the screen is down and you can see some solder in there on the PCB. I was trying to investigate where that came from. And you can see that it's falling downwards and it's coming off of the 3-phase motor windings that connect to the PCB. Crazy. So looking even closer, I could see that some of these components are shorted. Like it looks like this Hall sensor is shorted to that red wire there. Could explain why the motor was making those weird noises when I was trying to accelerate. You know, it's dumping power in and one of the fields are shorting or the Hall sensor is shorting and it's getting erroneous data. Yeah, you can see 3 or 4 spots where the solder is just melting. You see there's hardly on that U1 there. It got so hot that the solder melted away on U1, V1, and W1. So yeah, this here was probably also shorted. That's no small piece of solder, bridging and connecting 2 pieces that shouldn't have been connected. So I mean, it seems like you had put too much solder in there, and what's causing it to get so hot that all this solder is melting? So here I am tearing into the other side, taking a close-up look. It's not as bad, but I mean, it is rusty, and there are some little specks, something in there. Don't really think those are solder. The magnets look good though. Like the grouping and the spacing on the magnets for the most part looks good, except for that one right there. And then I saw this, the piece de la resistance. Check it out. Yeah. There's one of the 3-phase wires, and it was actually touching the inner, what do you call that, plate of the motor. And look how it's blackened. It's just been shorting out and arcing. So that's crazy. I was having performance issues with this where it just wasn't accelerating right, and this here is one of the reasons. So I'm scraping at it just so you can see that it is the wire, it's copper, it blackened because it was arcing. Yeah, when things arc and burn, they blacken, right? So both motors had a problem, and here we are many hours later after I wrapped some more durable. This is actually meant for an entirely different application. This is the real duct tape. Yeah, it's aluminum, so it won't compress, and the adhesive on that stuff is meant to go from hot to cold on heating and ventilation, air conditioning systems. So I think I went around a dozen times, and so we added an extra 2.4 millimeters to the external diameter of the motor itself to increase the interference fit between the hub motors and the polyurethane wheels. And here I am powering it up. It's running a hell of a lot smoother. The wheels are not wobbling as they were, and it's not knocking. There you see the second mounting post, which I told you broke. I tried gluing it, glue didn't work, and then I later went at it with a mini torch and just melted it back together. I'll drop a picture in for you to see. So here I am riding it after fixing it how many times? For most people, this thing would be in a garbage bin somewhere because they're not going to have the technical skills to be able to go in and do this. It's not something that an end user should have to do with a brand new product. So it's actually performing pretty decent. I was concerned about that one motor, the phase wires where they connected to the PCB and all the solder having gone missing. I thought about putting more, but if it just heats up and melts off again. So I just left it the way it was. If it fails, it fails. And then this is me tearing into the battery and pointing out some of the spots just where the heat shrink had worn through, which could be a concern. I mean, you're starting to see the metal of the 18650 there, so we've worn through 2 layers of vinyl, so could eventually wear into the battery cell itself. Tearing in, notice on it says it's 2.2 amp hours. That's 2,200 milliamp hours. I will be testing these cells. So they use this interesting medical or fiber stranded tape, which was a real pain in the ass to get off. I wonder how strong that stuff is, if it's actually stronger than Kapton. Maybe I'll buy a roll of it, use that stuff. Looks pretty good. And there's the tiny little BMS that's on it. Desoldering everything was pretty straightforward. Heat up the tabs, remove the wires, all while being careful not to short anything out. I'm pretty sure the battery still had a little bit of a charge. And here's where you got to be careful, because all those metal tabs are really sharp. Look at this tab welding job. Well done. High quality. INR 18650. So I put them on my Opus BTC 3100 chargers and I ran them through a charge test. I didn't catch that on camera, but I'll put the results on screen here. So let's see, what else do I have here? I made a battery pack that fit in the MaxFind, and then I built a larger custom battery. Nothing is hot. That's the best it's been since I bought it, after putting hours and hours and hours and hours of work into it. Consider that before buying a MaxFind dual motor hub kit. My last discovery about the MaxFind garbage is this power charger model HK-42-2000, universal input 100 to 240 volts AC, 50-60 hertz, 1.5 amps, output 42 volts, 200 milliamp. If it was putting out 2 amps at 42 volts, I'd expect it to be a lot warmer than it is. I'm charging a 3P10S through a BMS, and the BMS is cold. So let's check the back voltage here, which should not be high, therefore the charger should be in constant current and putting out 2 amps. Pack voltage is 39.5 volts, nowhere near a full charge of 42 volts, and I would expect it to be putting out a full 2 amps. And to check the current, so with the digital multimeter, you see it's 1.2 amps, 40% lower than it's rated on the pack and in the materials that come with the MaxFind kit. That's a joke. I thought I was at least going to be able to use the power charger, but I guess I'm going to have to replace that too, sitting here waiting for a 6.4 amp hour pack to charge up at 1.2 amp hours. That's going to take hours. Alright, that's it. Disappointed with the MaxFind. And yeah, don't buy a MaxFind. You're better off building something yourself. Thanks for watching. Subscribe.